So kind of just to preface this, with everything that Benjamin's said, one of the main things that we're able to look at as part of this mass scanning and mass crawling that we're doing is JavaScript. So one of the capabilities that we have as part of the crawling that we're doing is the ability to execute client-side code. So when we're using our virtual browsers, we are navigating the different websites just as a normal user would, as Benjamin explained. And we execute client-side code, and we're able to look at all the different sources of code that's presentable to any other normal user. One of the things that we're specifically looking at is JavaScript. So our intent for being able to look at JavaScript is essentially being able to find skimming telemetry. So one of the major threat actor groups that we've been tracking over the past, pretty much since the inception of RiskIQ, is Magecart, right? Magecart is a threat actor group that uses various scripts to essentially steal credit card data from retail sites. Now that presents itself in different ways. It could be instances where the code is visible on the entire site, on different pages. It could be more highly targeted attacks and more unique attacks where the script is only presentable on the checkout page, right? The only intent of the script being placed on the site is to steal the payment data. Now, Passive Total is a tool that you can use as a result of specifically when Benjamin spoke about host pairs. That's us collecting the document object model from a site, parsing it, and then indexing it, meaning we're looking at all the different URLs and hosts, domains that are being called out within that document object model, and we're parsing them and indexing them within Passive Total. So what we'll run through today is I'm prefacing this that we're starting off with a known bad, but we'll get to a stage where we'll look at a couple sites that we'll see that via the host pairs section, they are sourcing scripts from hosts that may seem generic, may seem familiar, are intended to look as normal, but in fact they're tied to infrastructure that's associated with Magecart with skimming. And then I'll show you information as well, telemetry from our backend, from an actual crawl that you don't necessarily see in Passive Total. But it's kind of the heart of our capability, where you're able to see the actual script, the JavaScript resource URL that's being called within the document object model of the website. And then in addition to that, the actual script content of that JavaScript URL. And then what we'll do, we'll pivot to a few tools that are free and available to everyone. And we'll use them to decode some base64 encoded code that we found on one of the sites. And we'll also use it to deobfuscate JavaScript that's obfuscated. Now, the intent of showing you this as part of a webinar is to obviously show you the capabilities of data that we have, but B, it could be a tool that you use as responders, as security operations individuals, protecting your websites and your organizations, that when you run through this information on Passive Total, having an eye out for aspects that seem foreign, and then also understanding what is the background that may be occurring there. At face value, if you are not familiar with your website, an individual may see these certain hosts being sourced and maybe think that they're benign, maybe not give too much thought for them. What I want you guys to get out of this is the ability to look at the minute details from within the crawl data and the data that we're presenting in Passive Total, and then be able to take it a few steps further and then understand what is the nature of that host or those foreign sources being used in the website.
Can I just mention one thing? So what I did was in the chat, so if you go to the GoToWebinar control panel and you go to the chat section, I posted links to all of the tools that we're going to be doing, so you don't have to Google them. They're all listed there. And then I also gave the first initial query that OR is going to be doing. And so what you can do is, as OR goes through this, run the query, follow along, and see how he does it. So then you can see what happens. Okay.
Right. And then what I'm going to do is I have all my tabs pre-populated. I'll tell you where I would click, but I have them all preloaded, so we don't need to waste time with page loading and potentially slow internet. So starting this off, our first starting point for the investigation is this IP address 185.195.26147. Now, this is, again, as I said previously, a starting point for us, which is known bad. And then I'll talk to that idea of either starting with a known bad or starting with something that's an unknown in general a little bit later. And like I mentioned, our goal here is to identify any type of hosts that are being sourced that are not recognizable, not familiar, and then reach the conclusion of, okay, is the site, if we are assuming that a couple of sites that we're showing today, if we were responsible for their security, can we come to a conclusion that says, is it affected by Magecart or some sort of credit card skimming technique at large? What are the scripts actually doing? And has the infrastructure proliferated to other websites? Is it affecting other websites that may be mine, may not be mine, may be my partners, but you get an understanding of the nature of the attack. So with that, let me switch to my browser. And Benjamin, can you just confirm that you see my passive total?
I see your screen, yes.
Okay, wonderful. So what we have here, this is the first URL that we're looking at, right? And this is the IP address that we just mentioned within passive total. So getting a quick look at it, we can see we first viewed this IP address in March 2018, and as recent as the 4th of June, and one potential indicator that it's based in Russia, maybe something that helps us, maybe not. And we can see on this heat map is these are resolutions per day. So each one of these little boxes represents a time period of a day. And on here, we can see the different domains that have been resolving to this IP. And each little orange marker that we have here are new unique resolutions that we've identified.
Or can I ask you something? So can you mention about the Analyst Insights, because people that are the free community users won't know what that is?
Right, so what we have here at the top, these Analyst Insights that are basically a drop down here. You will not have this if you are a community user. This is a function of a paid user. And what these are quick tidbits of information that when you quickly look at and initially look at some sort of indicator, we are highlighting these pieces of metadata. For example, we can see this IP address, it's been blacklisted. It gives us an indication that there's already some negative nature that has to do with this IP. It's not a Tor exit node. Open port was detected 12 days ago. It's not a proxy. Host last observed 24 days ago. It hosts a web server. So this gives us an idea as to what is the nature of this indicator that we're looking at very quickly. It's color coded, right? So the things that you need to read are in blue and red, and the things that you don't need to read are shaded. So this is a function of a paid user that just gives you more information upon the first look. Does that help, Benjamin?
Yeah, thank you. Thank you.
Cool. So what we're going to specifically focus on for this use case is being able to see these resolutions in this first tab down here, where we see there's a total of 36 resolutions over the time that we've analyzed and observed this IP. And what we can see here, we scroll down, different domains that have been resolving to this IP. Now, since we know already that this is an infrastructure that's associated with Magecart, it's kind of easy to make the assumption that some of these are probably bad, right? But if we didn't know that, you can kind of see here that there are domains that may attempt to look normal, but may not if you have familiarity, right? So we see things that relate here to JS, JavaScript. This is .cloud. This has API in it, CDN. We have JS, CDN. The idea here is we can quickly get an understanding that this IP may be related to information that is used, right, for potentially JavaScript, right, JS, API, content delivery network. Okay, makes sense. If we didn't know that was bad, gives us an idea. Maybe this has some sort of infrastructure associated with it. Kind of a weak conclusion, but nonetheless. And we can all see these are fairly recent, right? They're all from May in terms of the last seen.
And
we specifically chose that as
sources as well.
What's that?
Somebody had asked the question about the DNS and like our sensors. And I mentioned about like how we show where our sources came from. So can you mention that as well?
Yeah, so we're transparent about where we're sourcing the data. You could see that some of these, in terms of the data that we have about them, are coming from VirusTotal, and some of these are coming from us as well. So in cases where we obviously attempt to crawl the entire internet, we definitely don't do that, right? The internet's vast and we're open and transparent about that. In cases like that, we're sourcing data from our partners, from companies that we work with, and then we are listing that in terms of the source, so it is transparent from where that data is coming from.
Thanks.
So what we'll specifically focus on here is the second domain resolution that we're seeing here, cdnpack.net. Now, when you view this, again, if you are not familiar, you can maybe make the assumption that this has something to do with content delivery network, potentially providing content to websites. But it's a .net domain. It doesn't look like something that may be familiar if you are familiar with your website and the sources that are being brought into the page. And we're going to specifically focus on this one. When I initially did this investigation, this immediately caught my eye because I said, okay, this looks kind of crafty, right? This looks like something that could be looked at as generic or benign, and that the fact that it was attempting to do that kind of caught my attention, and then I drilled down on that. So in the next tab, I have the pivot on cdnpack.net. And again, with the Analyst Insights, you see these two red buttons, right? It's been blacklisted 3 months ago. The IP we were just looking at is blacklisted as well. And we'll specifically focus here on the host pairs. But before that, we can see the resolution of this domain has not been consistent. All right, that's another flag immediately to the eye. It says, okay, something weird going on here. If it was a normal, potentially content delivery source, wouldn't we expect it to be up consistently and constantly? Otherwise, it's not a reliable source for content delivery. Another potential red flag. What we're looking at here, aside from all these other tabs that we have here, like I mentioned initially, is host pairs. Host pairs, as Benjamin mentioned, parent-child relationship between the website and sources that are brought in, depending on what the source is. So we can see in this case, cdnpack.net is being sourced from this site, caddydaddy.com, for scripts. And we can see that this has first been observed in March 2020, and as of recent in May 8th. So this gives us a quick understanding in this case that caddydaddy, potentially orderline.com, but we'll leave that alone as well, were two initial targets that cdnpack.net was used against, right? Now in this case, again, we still haven't made the conclusion that cdnpack.net, because that's part of the goal of the investigation, but we can see it affects this website, caddydaddy.com. So the next pivot that we'll do here is investigate what is caddydaddy.com. I have this in our next tab here, and I'll come up here and give you a look at how it first looks. So there's no red buttons at the top. It's not blacklisted. There's been a new subdomain 4 days ago. It's registered. We crawled it. It resolved. We can see a consistent pattern of resolutions to the IP, which gives us an idea that this site has been up and is potentially legitimate. And now, again, I'm specifically focusing on this case within our data set on host pairs. So we saw that there was a connection to cdnpack.net, and we can confirm that looking at the host pairs. And we can see things that look legitimate here as well, like translate.google.com and paypal.com and googleanalytics.com. These are the legitimate sources being used in this website. And if we come down here, we can see the relationship of cdnpack.net from April to May, right? So it confirms what we saw in the previous screen, which is fantastic. Now, just to get an idea of what caddydaddy.com was, I initially did some Google searches and I was led to this parts store for Cadillac, custom Cadillac parts that is not far from where I live in Napa, California. So this looks to be a legitimate website, right, that's selling different car parts for Cadillacs for people who are customizing Cadillacs. Okay, fantastic, right? We know what this site is. Now, the next part of this is when we look at the host pairs, from the view that we get from Passive Total is a broken down document object model. That's essentially how I view the host pairs. Now, this is a result, as we've been mentioning previously, of RiskIQ crawling CaddyDaddy throughout the past year and collecting the telemetry, indexing it, parsing it, and then recognizing any changes. What I'll do now is I'm pivoting out of Passive Total to be able to show you how we view the document object model in its raw form from caddydaddy.com and how we can see that cdnpack.net is being called out to as a JavaScript resource, and then we'll look at the actual script content of cdnpack.net within caddydaddy. So I'm pivoting again, as I mentioned, to our back end. And this is the result of our crawl on caddydaddy.com. And I specifically have highlighted here, like I'll just scroll down and give you an idea. This is all the code that we've collected from the DOM. And I'm specifically highlighting this section right here of the JavaScript source. We can see HTTPS cdnpack.net/cdn.js. This is how, in Passive Total, when we crawled this website, we saw that cdnpack.net was the resource URL for this JavaScript resource, and then we've listed that as a host pair. So again, there is a certain gap of what you can see from our backend, obviously, and then what you see in Passive Total. I just want to give you an idea of how this looks and then what you can then do if you have this capability to be able to look at the actual script content.
Or can I ask one thing? So we don't use any agents installed anywhere on any machines to go gather this. This is all from us acting like the real user and interacting with the website like a real user, correct?
100%. This is us consistently visiting the site of caddydaddy.com as a normal user would, emulating normal human behavior and collecting the information that we get from that interaction.
Thanks. Thank you.
So now the next thing that we need to do is we need to understand what is the nature, what is the content of this JavaScript resource that we see is related to cdnpack.net. So the cool thing about our collection is we actually collect this script content. And I'll pivot to another tab where we have the actual script content of this cdn.js file that's being sourced in caddydaddy. If I go up here, a lot of text, a lot of code, gives you an idea of the full amount that we have here. Now, specifically, what we have down at the bottom, which is a common trait for credit card skimming attacks, is to have the code that's related to the skimming activity at the bottom of the DOM. Now, what we see here is that there is some sort of encoding being used as part of this script. So in this section that I've highlighted, this is what we're specifically going to focus on in terms of the bad aspect of this script resource. So we can see it starts with the var right here and then goes all the way down to the end of the script. Now, one technique that our researchers use here is decoding this script, right? And for that, what we can do is use an online tool where we'll pull these individual unique values that we see here and here. We'll remove the quotes and the commas, and we'll put these actual values. We've parsed them, and we'll put them in a free online tool that does base 64 decoding, right? So this script has been encoded. We want to decode it and understand what the actual values that this script is looking for. So if we pivot to a free tool, base 64.
Can I ask one thing? So yeah, we automate this to find this automatically for customers, but what we're showing is a manual process on how to do it, to show you what it would take for you to do it on your own. But we actually have a product that does this for you and monitors it automatically. But what we're showing you is a manual process to do it and what you would have to do as a threat investigator to do this.
Correct, 100%. So what we've done is parse that code, right? We remove the individual characters of the quotes and the commas. And I've structured it specifically here, line by line, with these different indicators. We put it into this section here that you put in the raw code, hit decode, and then what we can see is the true values of this encoded text. So if we look here, these first values that we see at the top relate to last name, email, street number, region ID. So this is the different type of information that the code is looking for, and then skimming, i.e. taking it away, sending it off to somewhere else. Where it's sending it off to, the drop server domain in this case, is cdnpack.net. So whoever's controlling this domain is having this information being identified by this script for these certain parameters of information, and then it gets sent to cdnpack.net. If we continue down here, there's a public key that we see here, and there's more information that relates to payment information, right? We could see CC number, credit card number, expiration dates, the month and year, the CVV code, right? So this is all information that when you have it in your, right, when we all shop online, this is a different type of information that you put into a checkout process, right? Your address, your personal information, your actual specific credit card details, and then you hit checkout. That information gets routed to the retailer, your credit card gets charged, and then you receive the product eventually, right? So in this case, this script is looking for this information, harnessing it, sending it out to a different origin, different destination rather, and then the information gets stolen from the user to a threat actor, which then can go make fraudulent charges, can take the PII for other uses, identity theft potentially. But it's a cool way to then, if we just kind of recap, we started off with cdnpack.net. We saw how to relationship on the website. We specifically looked at the nature of the DOM. We specifically looked at the nature of the script being called out, and we see now that the indicators within the script are looking for PII and then credit card details. Now, the next thing that we want to do is we want to see, so we can conclude in this case that there is some sort of attack going on here, some sort of infection on the website that is an irregular source that's being sourced cdnpack.net on the website that may seem unfamiliar to us if we're the owner of the website. And then when we unpack the code and look at it, at its content, it's sourcing for information that it shouldn't be, right? If this was a real CDN resource, why is it identifying the credit card information as part of its behavior on the website? So our first objective to understand whether our site, caddydaddy.com, is affected by credit card skimming activity, highly likely in this case. The next part that we want to do is see if this attack has proliferated, has it moved somewhere else, has it changed nature, is it affecting other sites? So what we do here is we're coming back to our search and passive total of caddydaddy, right? This is the main section that we saw the information relating to that website. Now, what we're doing here is we're coming down to the date that cdnpack.net was being sourced as a script resource for the site. And what we can see is another weird looking domain here, cdnn-aws.com. I know AWS domains. Doesn't look like this is something that's familiar. CDN with 2 N's -AWS looks irregular, but potentially another attempt by the threat actor using a domain like this that at first glance you see aws.com and potentially make a slip and assume that this is something normal. And we can see that it started being sourced on the same day as cdnpack.net, and then over time cdnpack.net is dropped. So it transitioned for one day to cdnn-aws.com. Kind of weird, right? If this was a legitimate CDN, again, source, when we expect to see it consistently being used on the website. Now, this is the second part of our investigation where we're pivoting to new infrastructure to be able to see proliferation and movement of the attack. So as Benjamin initially mentioned, infrastructure chaining is sort of the core intent of what we're doing here via Passive Total as responders, as investigators, as threat hunters, as researchers, whatever it may be. You need to be able to look at this information, identify pieces that seem irregular, pivot on them, and then find more infrastructure. So as we started off with an IP that we knew was associated with badness. We were looking at what domains resolve to the IP, right? cdnpack.net. And then we saw what relationships does cdnpack.net have with other infrastructure. And we got to Caddy Daddy. We're going to do the same thing here with cdnn-aws.com. Before we start the second part, are there any questions? Benjamin, should we do a question check?
Yeah, there was a question. Any demo of the manual or automated process of the JavaScript code deobfuscation after beautifying it? It looks like only the base 64 encoding string was covered. Were there any other ones that we need to cover, or is that?
So that's what we're going to do in this next section. In this next part of the investigation, we're actually going to deobfuscate the code that we see from cdnn-aws.com. So preempted me a little bit, but we'll get there. Just a few
Okay,
minutes.
perfect. Okay, great. Thank you.
Okay, so with that, yeah.
Can I touch it? So somebody had a question about, hey, they couldn't follow along. The SF part is our backend system, and that's kind of what our platforms use to gather this data and take action on it. So that's like the raw data of what we've gathered. So you don't have access to that, but when I show you my piece, you'll see how it comes into the platform in the enterprise products. But we're just trying to show you with the raw data what happens and how we can take it and deobfuscate it to show you the manual process to do it instead of just hitting one button. It's all done, here it is. So we're showing you how to hunt and gather on your own, and that's what we're attempting. Okay.
Correct. We're aware that we're showing you a piece here that's in our back end. However, this is something that you can actually go to Caddy Daddy. If this was current, you could go to the website and even within a browser, look at the actual document object model and look at the specific resource that's being sourced from cdnpack.net, and then be able to look at the potential script content that's being called there. So there's ways to do it. We obviously showed you just from our back end to show you the view of how we view it and then how we index and parse that data and make it viewable and how it manifests itself within Passive Total. So there are steps here of information that you may not have access to. This is intended to be an illustration of when you see something foreign, how can you then dig in and understand what the nature of it is and why could it be something that needs investigation in general. So the next part here, cdnn-aws.com. Let's pivot on this specific domain. Right, so again, same kind of lookup. We see first seen in January, last seen June 24th, so yesterday. Again, resolving IP blacklisted. And we can see potentially some sort of timeline here that looks like normal behavior. It's been up. We can see two IP resolutions over time. Maybe this is a little bit more consistently used compared to the previous one. Okay, conclusion there. Now, again, specifically here, focusing on the host pairs tab. What we want to see is what other relationships does cdnn-aws.com have with other websites, with other hosts. So what we can see here under host pairs, we have 13 entries. These 13 entries, if we only focus on the ones in the past recent months, we can see a checkout, supatx.com, Godspeed Project, Computer Orbit, Facebook.net, we'll leave that out, buypcsupplies.com, and rev9power.com. So on the face of it, I don't know what all these websites are, but we can see that this resource is being used, being sourced in other websites, right? So if I pivot on this first one, the checkout.supatx.com here, I'm trying to get an understanding of what these hosts are, what are these domains, what are these websites, and then see what is the relationship with cdnn-aws.com, as I did previously with Caddy Daddy. So I'll pivot to the supatx site. So this looks a little bit more normal, right? I have a full history of resolutions over time with not much change that I can see in this heat map. The resolving IP is blacklisted. That may be an indicator here. May not be. It may be that at some point one of the IPs that this domain was using was associated with some sort of reputational data that was negative and it's been classified as blacklisted. Can be and may not be. So again, let's go to host pairs where we can actually see that CDN, the domain that we're looking at, is being sourced as recently as the 24th as a script resource. So this is simply confirming what we saw before. Now let's get an understanding of what is this site. So I initially Googled this, and then I come and I see that this retail store is selling SUPs, right? So these boards that you stand on, and they're like a hybrid of a surfboard where you go slow and stand on them. Okay, fantastic. I know that it's a retail site where there is a shopping cart and financial transactions can be conducted. So now again, just for transparency, I'm pivoting out of passive total and again going to our back end to show you how we view the relationship that we're manifesting here in terms of host pairs, how it looks for us in the back end, how we view the actual document object model of this site when we crawled it with our virtual users. So if we go to our back end, this is our site, checkout.supatx that we saw. It's actually SUPA, right? supatx.com that we saw in passive total. And I have done a quick control F and I can see our resource here, cdnaws.com, is hosting a resource which is init.js. So again, as we've collected this, we parse out cdnaws.com and then we list that as a host pair in passive total, right? So this is how we got to identifying that this may be something bad. The next part of this is, as we did with cdnpack.net, is I want to understand what is the nature of this JavaScript? What is it actually hosting? What is it delivering? What is the nature of the script? So as we did previously, we actually collected the script content of the JavaScript. And in this case, a shorter piece of code that we see here compared to the one that was on the caddydaddy.com site. So in this case, this JavaScript is obfuscated. So what we can do is we can put it in a tool that we linked to at the beginning, which is a JavaScript Beautifier. It breaks down the code and makes it more structured, where we can actually see the different functions and the nature of the script set up correctly in a way where it's easier to read. And what we can do here is we can look at the nature of the script, and a specific piece here which is raises a red flag is we have a string here which has the same base 64 encoding that we saw in the cdnpack.net resource. So again, what we can do here is take this specific string. specific piece of text right here, L9, all the way to this equals equals. Put that back in our tool, hit decode, and we're seeing that this is our essentially our drop server domain that may be sending the information to the domain owner. Now, in this case, we don't see that this specific JavaScript is looking for the same parameters of information as our first one did, right? We don't see here any indicators that look at credit cards. We don't see any PII indicators here. So this is kind of weird, right? Why is there just a component here that relates to our drop server domain in this case? What we have here, we had our researchers look at this, and basically this is a different type of skimming technique that only includes one stage of the skimmer. Now, this could usually be intended to only fire off within the checkout page, meaning once a user goes through the checkout on that subboard site and starts adding information, another stage of the JavaScript gets loaded, and that's where it will contain the actual skimmer. So in this case, this is a two-stage Magecart attack, where if you don't go through the checkout process, you may not see the actual skimmer. You see components of it, but you may not see the actual nature of it. It's intended to potentially be a little bit more stealthy, maybe more undetectable, or simply that the way that the threat actor crafted this attack is to only operate on the checkout page. So a different nature of the attack that we saw in cdnpack.net, right? And then this one that they then transition this infrastructure to use this new domain. The skimmer has a different nature. The other one was viewable at first scan, without needing to go through another action, without the user requiring to go through another action. In this case, the user actually needs to go into the checkout page, put information in, go through the process of adding different PII and credit card data, and then a second stage of the attack gets loaded. So it's a two-stage attack. Now, going back to passive total, let's see what other sites this this domain, cdnn-aws.com, is affecting, right? We see this list here, checkout, SupaTX. Okay, we can say that's potentially affected, right? What is godspeedproject.com? So again, pivot to that, open this in passive total, same deal, look like a legitimate website. It is blacklisted. Now, for our intents and purposes, it's blacklisted because we actually found Magecart on this site. Let's assume it wasn't blacklisted previously and you're doing your investigation. This looks like a legitimate website, right? Consistent resolutions over time, consistent uptime. We look at the host pairs here again. We're looking at different sources, right? So googleapis.com, google.com, facebook.com, and then here is our target that we're looking at as of the 23rd. So now the next thing I did is, again, I Googled Godspeed Project. I see that this sells the car parts, suspension parts, coilovers specifically that they create for suspensions. Cool, I know it's a retail site. Next part, again, we'll go through the same process of looking at our crawl from Godspeed Project, and we have the same type of script, init.js, being called out to. We can conclude that there is potentially skimming activity occurring on godspeedproject.com, just like we saw with the site for the subboards. Now let's go back to our next resolution here that we saw. The next, relationship, computerorbit.com. Again, same deal. Looks like a potentially legitimate site, does have the blacklisted since we scanned it and we've identified the skimmer operating on this site. But again, same deal, right? Legitimate sources being used here, but then we have our one foreign one. And just to understand the nature of the site, I can see that it's a retail site selling computer parts. Fantastic. Let me look at the document object model that we've collected as well. Same deal. Same deal, we have the JavaScript being sourced here, and then we'll go to another host that we saw the relationship with, buypcsupplies.com. Again, same process. Looks legitimate, has legitimate sources, contains a relationship with our target domain here, and then we're able to look at the fact that it's also a retail site, and then look at the document object model and see that it's being sourced in the same resources being sourced. So that pretty much concludes these two different types of investigations that we have here. So let me just pivot to my PowerPoint presentation here.
So Barrett, are there any questions that have come up with this? Because this is an advanced investigation. So we wanted to show you something where we took a known bad, and from that known bad through infrastructure chaining and from the advanced data sets that RiskIQ has, because we know the pre-computed map of the internet, because we know what comes in and goes out of all the websites, to find something that is also affected. And one of them was already cleared up. You can see that it was no longer, we've seen that script being run there. But then we pivoted from that one to find current ones that are currently being affected. So we're showing you a manual process, and we were showing you tools that you would have to, that you could use to potentially get this work done. But you have to also remember that if you're using a checkout or something like that, that you're relying upon somebody else's code, they might get popped and you get popped because you're using them. One thing is, if you're buying something online, it's a lot safer to use something like PayPal, where your credit cards are already stored, and then you're using that checkout to do it, where your information is not sent through the website, and you're not inadvertently having your PI stolen your credit card information. So those are some things that you can think about. Now, Barrett, are there any questions that have come up since we've ended this?
Yep. Benjamin, there's one around host pairs, and maybe you guys can elaborate a little more on this. Can you help clarify the relationship between the parent and the child?
You want to take this, or what is considered the parent and the child? I think
yeah.
No, yeah, go ahead.
So basically what we're seeing is there's two relationships between the host, right? So Benjamin, correct me, right? The parent is sourcing from the child. Is that correct?
So think of it this way: if I search for something, there's a parent and child relationship. So the parent comes in and the child goes out. But it depends on what you're searching, because then if I search whatever was that parent to begin with, the relationships might change. So it's always in the perspective of what you have searched. But the way that I was taught was, it's like your parent tells you what to do and you can tell your child what to do. So it's kind of that flow where you reach out, you grab the parent, it comes in, and then you might be sending out something to the child.
Right, and again, the intent of this, of displaying this whole process and showing aspects that you may not have access to, is if you are one of the owners of caddydaddy.com or any of these other ones that we looked at, you are more familiar with the different sources being used on that site than an outsider is. You surely know all the different sources and behaviors that the website exhibits and uses. And then when you come across something that is unknown, that is new, how do you take that investigation and take it a couple levels deep? Whether you use help from us, whether it's information that you can gather on your own via different tools, how do you come to the conclusion that some aspect that you see here that is unknown may potentially be bad, negative in nature, and then what is the actual nature, right? It may be bad, but what type of badness is it? In this case, these are scripts that are essentially just stealing credit card information, right? It's typical cyber crime. It's theft of payment information that somebody can then go and use for their own benefit.
So we had a great question. Somebody asked about the first and last seen dates. So when we go out there and we crawl the internet, if somebody put a script on there and we saw it, and then they took it off and we went back and it was gone, that's like a first last seen. But sometimes somebody can put a script on and we already had scanned them, and then by the time we come back, it's gone. We might never see it. That's like the tree falling in the woods. Does it make a noise? But generally, when you see that first and last date, and if it's no longer after that last date, that's generally when it was cleaned up. So you can tell when a site was affected and when it was cleaned based upon when we detected that script, for example, being used. Great question.
And then one other aspect that we have as passive total users, you can actually establish monitors and alerts on change of infrastructure. So if we're looking, for example, at an IP and there's a new domain resolution, as one of the bonus questions we had here is like what features can be used to monitor changes in infrastructure. So we have an alerting mechanism on passive total that can alert you to changes in infrastructure. You have the ability to create projects, which are essentially case files. So you can add this infrastructure, establish monitors on it, and then rather than manually tracking its updates or its deltas, you will get an alert that will notify you that a change has been occurred.